In this video, I'm going to show you a completely free way to build film emulations that match or beat nearly every LUT and plugin out there. Along the way, you're going to learn what truly defines the film look, why it's so hard for us to achieve digitally, and the difference between an emulation and an imitation. Okay, we've got lots to cover here in Resolve, but before we get hands-on, there's a few basic concepts that we need to cover. And the first is the film look itself. So what is the film look? What makes the film look? Well, you're going to hear lots of different ideas and opinions on this topic floating around out there. But at the most basic level, the film look is always going to require two things: a film negative and a film print. You can't even get a film image without these two things. So of course, you're going to need them if you want to get a film look. And what this effectively means is that the film look is inherently what we can call display referred. That just means that it has been made ready for display and it is visible on some type of screen. And this makes perfect sense if you think about it, because if we're talking about the film look and being inspired by it and wanting to emulate it in our digital color grading workflows, we would have to be inspired by seeing something, right? So having a film look be display referred just makes perfect sense. But where it gets interesting is that we run into a problem when we're trying to incorporate that system, that film look, into that digital color grading workflow. Because on one hand, we have our film print, whose job it is to put the image on the screen, to make it visible. And then in our color management framework, which we should always be using when we're grading, we have a component with a really similar task. That's our output transform. And what happens is these two things stack on top of each other, and we get really weird looking results when they do, right? When I first ran into this years ago, when I was first getting into film emulation and color management, I spent a very long period of time trying to figure out the best way to get these two systems to connect together and play nice together. And I ended up coming up with a really good solution. It's actually the solution that I used to build my Kodak 2383 emulation that I make available for free here on YouTube. And what we're going to do today is walk through that full process that I designed end to end, step by step, so that you can build film emulations just like I built my Kodak 2383 for yourself. After we finish doing that, I'm going to walk you through the pros and cons of this workflow and really what it means to emulate film inside of a color management workflow and how that's going to affect your grading practice and your final images. Okay, two more things before we get started. Number one, today we're going to be focused on the contrast and the color component of film emulation. We're not going to be focusing on textural things like grain and halation, just because we've got enough to bite off just on the contrast and tonality side, or the contrast and color side, I should say. So texture is something we can save for another video. You're also going to find that once you're up and running with this process, this pipeline that I'm going to help you design today, it's actually very easy to incorporate those textural pieces on your own. And then secondly, I also want to emphasize today we are doing strict emulation, meaning that we are going to be using actual measured data from the behavior of real film as the basis for this film emulation. So this is different than an imitation, where we might just look at a film image and say, oh, I love the way the shadows feel or the highlight roll off, or I like the way that skin tone is being rendered and I want to mimic that in my own grade. That wouldn't be a better or worse way of going about things. It would just be a different way of going about things to say, I'm going to imitate those characteristics that I like. You might want to imitate those things with Resolve native tools. You might use a look development plugin like my plugin Contour, for example, but that would be a fundamentally different approach than what we're doing today, which is about emulation, which is about using measured data about the behavior of real film and incorporating it into the emulation that we're going to be building today. Okay, let's get hands-on in Resolve and see if we can build ourselves a film emulation pipeline. So what am I looking at right now? I haven't done any grading yet, but I have gone ahead and set up my color management. This is the way that I set up my color management for all my projects. I've got my input transform going from my camera color space to my working color space of DaVinci Wide Gamut Intermediate. That for me is happening here at the group pre-clip level of my node graph. And then here on the other end at the timeline level of my node graph is my output transform. This is what is making my image look correct on my screens, what's giving it the appropriate contrast and saturation for my screen. Now, if it's been a while since you've thought about or worked with color management, or if you're brand new to it, I'm going to encourage you to pause this video right here and go back and check out some of my other videos on color management and how I like to set things up and why we set things up and what all this stuff is that I just walked you through, because I promise it's going to get more difficult to follow from here, because I'm going to assume you've got some basic literacy in these areas. So if that's you, hit pause, go check out some of those other videos. If not, let's continue forward and start building out this film emulation. So Here's what we're going to do. I'm going to start by disabling this output transform just for now, and we're going to start to build out this emulation. So we're building an emulation. What are our raw materials going to be in this construction? Well, we know what they're going to be. We talked about them right at the beginning of this video. We're going to need to build our negative and then our print and put them together, right? So here's what that's going to look like. We're going to use some Resolve native solutions for both of those components that are built from actual measured behavior of real film that we can sequence together to get that film look built out here in Resolve. So we're going to start with the negative side of things. And to build our negative, we are going to use a standard called ADX. This was developed by the same people who developed the ACES color management framework. And it was developed as a way of translating in between the color space of a film negative and the color space of a digital color grading space, something like DaVinci Intermediate, for example. So we're actually going to do this in 2 steps. So here's how it's going to go. We're going to go color space transform, and we're going to go from DaVinci wide gamut, DaVinci Intermediate, to ACES, AP0 linear. Now, as we start to build out nodes here, because we're going to sequence several of these out during our video today, it's always helpful to keep in mind what we're doing. We are always starting with the space that we are in, and then we are moving into some other space, and then we're going to pick up from whatever space we've moved into as the input to our next process. You'll see what that looks like as we go along here, okay? Now, thus far, I've succeeded in making my flat, boring image look way worse, but I promise it's going to get better. We're going to keep building this stack out. So let's label things as we go along. We're going to say this is to ACES. Why are we going into ACES right now? Strictly so that I can open up an ACES transform here and use a color space that it has available to me here in my dropdowns. So what we're going to say here is for my input transform, we're actually going to leave this at no input transform, which means ACES AP0 linear, the exact space that I just CST'd myself into in this previous node. And now for my output, I want to get into my negative space, and that's going to be ADX10. This is a generalized color space that's meant to characterize the color space of a film negative, and it's going to work great for our purposes today of needing to model that portion of the film look or the film pipeline. So we've now moved into our negative space, and I'm just going to label this, and we'll call this neg. This tees us up perfectly for what we need to do next. Next, we need to do our print. And hiding out right here in Resolve in our film looks folder, we've got some very nice film emulations. So I'm going to widen this out a little bit. Now, these film emulations ship for free with Resolve. In fact, my friend Walter Volpato, who was recently a guest on my podcast, used one of these LUTs for the show Winning Time, which he graded recently for HBO. Amazing looking show with some great filmic character to it. So again, don't sleep on these LUTs just because they're available for free right here within Resolve. We're going to use today the Rec. 709 Kodak 2383 D60. If you wanted something a bit warmer, you could use the 2383 D55. If you wanted something a little bit cooler, you could use the D65. I'm going to play Goldilocks and go for the one right here in the middle. And we're going to apply this to our image. And let's take a second here to admire what we've done. We have just applied this print LUT to a negative state of image. And the net of what we've just done is we've got a really nice film rendering of our image. We've achieved the film look here. So are we done? Well, not quite, because remember, we turned off this output transform here earlier. So we're kind of sidestepping that problem that I mentioned a minute ago that happens here, where we've got a print and an output transform that are fighting each other. They're bumping into each other. So we need to solve that issue. That's really where the craft comes into this workflow that I'm about to show you. So let's go ahead and label this node. And what we need to do from here is put something in between this and this that is going to make this look correct, right? So what are we going to do? Well, we're actually going to use a color space transform. And the fundamental idea here is that we are going to pre-invert, meaning invert ahead of the stuff that's happening here, so that the net of these two cancels each other out, or close to cancels each other out, okay? Now to do that, we're going to do something that I advise against on the channel all the time. We're going to go from I'm actually doing this backwards because I'm so used to it. We're going to go from a display color space, Rec. 709 Gamma 2.4, back into what's called a scene color space, DaVinci Intermediate. This is a very tricky thing to do well, and it's something we need to be very careful with. That's why I usually recommend against it. But if we get the details right, and if we do it in just the right way, we can get the result that we're after, which is an emulation that's going to play nice inside of our color management, okay? Now, we've got some more work to do, but let's again just kind of pause. I'm going to label this node and take stock of what we've done thus far. So now with the addition of this fourth node, I've gone from color management only to effectively film emulation happening across 4 nodes that is playing nice inside of my color management framework. So that's pretty cool, right? But devil's in the details here. We really want to make sure we're going to go in now and analyze every step of this chain and make sure that we are being as gentle to the image as we possibly can be, and make sure that we're not creating any room for problems or unwanted behaviors to crop up on other images when we apply this same stack to other images or other grades, okay? So here's what we're gonna do. I'm gonna prepend a serial node by hitting Shift S, and I'm gonna go over here to my gallery and to my utility power grades and just grab an instance of my Grayscale ramp. This is a free DCTL that I'll leave a link to in the description for today's video so that you can do this exact same thing. I like this one that I created because it allows me to see the Grayscale ramp here in my waveform while also continuing to look at the image. And so what we want to do is we're going to go piece by piece here and look at what each one of these nodes is doing to this Grayscale ramp that I'm looking at right here, okay? So let's start with our ACES transform. I'm going to turn this on. Now, this is the one of all these nodes in the stack where we can kind of ignore what might look like a problematic curve here. This looks like we're clipping out a bunch of data, right? We're actually not. What's happening is we are mapping into a linear domain where the range is much greater than 0 to 100 as we see here. So it's not that this is being chopped off, it's that it's continuing to go up above the range of my scope. So this is the one situation where I'm going to allow an ugly curve to remain without trying to do anything about it, all right? We're now gonna take a look at our neg, and let's see what happens once we apply this. So you can see we're getting stuff kind of falling back into range here, but now we are still getting some clipping in the top end, and this we can do something about. Here's what I wanna do. I wanna do some tone mapping to say, hey, whatever we need to do to kind of soften and roll things in just here at the very top, that's what I'd like to do, because if I think about, I don't know, a bright exposure out a window, or, you know, like a glint or a flare or something like that, I don't want a hot exposed element in my frame to have a hard clipped behavior. I would rather it gently roll, okay? So here's what we're gonna do that, or how we're gonna do that rather. Let's go back to this ACES transform, and we're gonna use some luminance mapping here. We're gonna say a custom max output of 10,000, because that's the max of this working space that we may indeed hit with the right image, right? And then we're gonna do a custom max output, and we're also gonna do that at 10,000 for now, just so that I can point out, if I set these both to 10,000, I'm getting no change in this curve, right? It's nothing additional is happening. So what I wanna do now is move this output slider as little as possible to get the curve back in range. You see what I mean here? It's just not quite in range here. Now it's going further than I need to. I want to go as far as I need to, but no further with this value. And that's going to be right around 2200 in this case, okay? And I want to point out something that we're going to see a couple times as we're going through this node stack here today. These nit values here are not particularly intuitive. Like if we look at this adjustment from 10,000 to 2,200, that sounds like a massive adjustment, right? Like if you had $10,000 and I took away 7,800 bucks from you, you'd be like, man, that was like most of my money that you just took away from me, right? Doesn't work quite the same way here. These numbers are not perceptually aligned, okay? So even though we're making a big numerical adjustment, there's not necessarily going to be that same scale of visible adjustment when we actually get this thing fully built out. We'll see another example of that here in just a little bit. So we've now got this tone mapped, and we're taking care to ensure that our curve is gently being shaped as we move forward through this stack, okay? We're now going to apply our print process. Let's see what we're getting here. That looks good, right? These curves feel nice and smooth, nice and gentle, no big problems there. And that's to be expected because I'm not doing anything fancy quite yet. I'm really just mapping this image for a traditional film reproduction or a print film emulation reproduction without needing to slide it into my color management. It's this next step where we're going to run into some challenges and really need to finesse what we're doing. So here in this step, we are, again, going from a display space to a scene space. So we need to be very mindful of how we do this, because essentially we're taking the fabric of our image and gently stretching it back out from the dynamic range that it was compressed down to for display by the print process, okay? So we're gonna gently stretch this back out, and here's how I like to do it. We're gonna do luminance mapping again. We're gonna set a custom max input of 100. And let's just say, for argument's sake, we're like, hey, I want the full 10,000 here. Can I get there? Here's what's gonna happen. If we go kind of large on our waveform, you can see this top end of the curve is starting to get a little kind of chunky and jagged, right? So what we wanna do here is find an output that's as high as possible so that we can get some dynamic range restored, but that stays smooth, okay? And usually for this workflow with film print LUTs, that's going to be somewhere in the neighborhood of 600 to 650 nits for output, okay? Now, remember, we observed just a moment ago, these numbers don't scale perceptually. So, you know, like if we're looking at, oh, I could have gone all the way to 10,000 and now I'm only going to 600, that sounds like a massive change. It's actually not nearly the impact visually that you would expect, and we're going to see that in a minute here, okay? So now we're, again, managing that curve, keeping it as smooth as we possibly can. We've got a little bit of jaggedness down here in the bottom of the curve as well. Like if I increase this ramp height, you can see that, but that's really just the result of this chain that we're going through and the fact that I am using a LUT that's only a 33-point LUT. It's not like a 65-point or super high resolution LUT. So there are some areas here as we're building this out where it's just the best we can do and there's nothing really further that we can do. We just want to make sure that anything we can do to be gentle in the image, we are doing, okay? So let's turn this ramp back down to 10% here. And we're going to continue forward and apply our last step next of our final output transform. And that curve, as you can see, is looking pretty good. So let's observe, now that we've done these last two pieces, fundamentally, what we are trying to get, let me stretch these scopes back out so I can get my vector scope visible as well as my waveform here, okay? And let's look at the scopes as I flip these last two nodes off and on. I am hoping to see little to no change in the image here, because remember, like, this is the film look right here. I just want to translate it so that it can work inside of my color management, right? So if I was seeing more than a small change in the image, that would mean that I wasn't doing things as well as I really should in this step, because I don't want to change the visual. I don't want to change the rendering of the image. I want to change the pipeline that I'm able to use to get that rendering. Does that make sense? So we are getting a small net change here, but we are maintaining the overall essence of the look, and we've just slotted it into our color management framework, okay? So we've got that set up. We've gotten nice and smoothed out in terms of our curves and working our way through things with our grayscale ramp. So where do we go from here? From now on, do you just have to stack these 4 nodes every single time you want to do a film emulation inside of a color managed framework? No, you don't. I want to show you now a way that you can cook all 4 of these out into a LUT that you can use and reuse whenever you want to. Now, here's another kind of tricky part that we're going to get into right now, because we want to cook out a LUT, but we want this LUT to only contain certain things and to exclude other things. So like with everything that we're looking at right now, let's just summarize our processes. We have an input transform. We have these 4 where we're going from ACES, or rather we're going to ACES. We're modeling our neg. We're going through our print process. We're converting back to DaVinci Wide Gamut Intermediate, and we're going back out to Rec 709. But we don't want to bake all of that into our LUT, because we want some of those pieces to come from our color management when we're using that LUT, right? So the main thing to be mindful of when you're cooking out a LUT is to make sure that you are leaving the right things on and turning the right things off so that you're cooking out the LUT that you actually need for use in your workflow. Here's what that's going to look like. We don't want this, right? This will be provided when we're doing our color management. We also don't want our input space, and this is the one that I always forget about when I'm doing this process. You want to go over to wherever your input transform is happening and turn it off, because I don't want to bake a camera to working space transform into my LUT. I want that to be handled by my color management. I just want a LUT that contains the 4 processes that we've just built out here that model my color management friendly, or my scene referred film emulation. And then I can build everything around that with my color management framework. So now that I've got the right things turned off and on, oh, and we can turn our ramp off as well. We don't want to ask Resolve to try to cook that into a LUT because it'll get confused. I'm going to even need it right now for any reason anyway. So I'm going to turn my gallery off here. And here's what we're going to do now. We're going to right click and we're going to say generate LUT 65 point cube. And this is going to point me to my LUT folder. And we're going to call this 2383 DaVinci wide gamut. All right. We've now outputted that LUT. And what I want to do is open my LUT folder and just check the name on it. So I'm going to go to my project settings, which I could get to from this gear icon here, or go to the file menu and hit project settings. And I'm going to go here to color management and then lookup tables. And we're going to say open LUT folder. And if you notice here, you'll see I've got this Kodak 2383 LUT here, but it's got this suffix on here that Resolve is always going to add. I'm just going to strip that back off so that I'm left with 2383 DaVinci wide gamut. I'm going to cancel out of my project settings here in Resolve. And we're now going to turn everything back on here in Resolve. And I'm going to grab a still of this. I'm going to use this as my reference to confirm that the LUT that we're about to bring in is doing what it should. Okay. So I've got my reference still pulled here. I'm now going to turn off these 4 pieces because hopefully these 4 pieces and only these 4 pieces are what just got cooked into my LUT. So when I apply this new LUT that I've just generated, it should do the exact same thing that these 4 things were doing before. Okay. So let's go to our LUT folder. I'm going to go to the root level. I'm going to right click and hit refresh. And I can see my 2383 DaVinci wide gamut living right here. And if I double click on this, I should now see no change in my image when I wipe between the LUT being applied and the still that I just grabbed where these 4 nodes were being applied. Okay. So that's the overall process. That's how you can build your film emulation. That's how you can cook it out into a LUT. You can experiment with different ingredients. You can experiment with different film look LUTs here within Resolve and look at different ingredients that you're going to use to build this film emulation. That's really going to be the biggest predictor of the quality of your emulation, is the quality of the ingredients that go into it and how well sourced that data actually is. But now that we've gone through this process, let's talk about the pros and cons of what we are fundamentally doing here and what you need to be aware of if you're going to use it, kind of going into it with like full context of what this workflow is and how it's going to impact your image. So a couple of the pros first. Some of these are obvious. Like the biggest pro here is that, hey, we're able to do a film emulation that looks almost identical to what I was getting without color management inside of my color management. That's cool. I can use the workflow I'm familiar with. I can target other display color spaces. Like that's a great benefit that I can now use a visually faithful film emulation inside of my color management framework. And the second pro I just touched on actually. Now that I'm in that color management framework, I can actually target other output color spaces. And I can target an HDR color space or whatever other color space I want to, because I've got this emulation that is now scene referred. It's living inside of my color management framework. That's pretty cool too, right? Let's talk about some cons. Let's talk about some drawbacks that we need to be aware of. Here's the first one. When you are doing this workflow, your image is only ever going to look as good as it did before. And in practice, it's probably going to look maybe not worse, but it's going to look a little bit different. Like you can see here when I flip things off and on like I did a moment ago. Let's pull this LUT out of the stack for now and just go back to our 4 raw nodes. And when I toggle these last 2 pieces off and on, the image is changing, right? Like not necessarily for the worse. It's not like one is inherently better than the other, but the image is changing a little bit. So we are disturbing the image a little bit. And this is really just a way of pointing out that the image is never going to get better than it was before. At best, it is going to look fundamentally the same as it did before, but it is not going to get better, okay? Here's the other drawback. These 2 things have to pair together. So what that means is that this only works for one DRT or one output transform at a time. For example, if I were to swap out my CST with a different DRT, like 2499, for example, if I were to swap this out, I would no longer be getting a symmetrical round trip. Now the image is changing quite a bit. Now, whether you like that more or less, that's really a topic for another discussion. But the point is that if I'm trying to faithfully reproduce this visual inside of my color management framework, I'm no longer doing it once I'm no longer using a symmetrical pair of inverse and forward transformation, okay? So TLDR there, this only works for one output transform at a time, okay? So those are the kind of big cons that we need to be aware of when we're working with this workflow. And what's fun about getting familiar with this way of doing things is it's going to show you something you can learn about any film emulation that you choose to work with from now forward, whether it's one that you've built or one that you are considering buying or one that a friend has given to you. Anytime you are seeing a film emulation that offers you the option of output to a scene color space, that could be Arealog C3 or DaVinci Wide Gamut Intermediate or S-Log3 or ACES or whatever it might be, anytime you're seeing a film emulation that is offering to output you into a non-display color space, some version of this process that we just went through right here has been used. That's a really important thing to understand. We've had to somehow reconcile the fact that film is display referred and color management wants a scene referred look in order to do what it's designed to do. So there's a fundamental tension there that we've just resolved in the best way that you really can, but it's still a compromise. It's still not perfect because we're having to do some significant changes to the image in order to make this pipeline work within a color managed context. So this is a really helpful thing to understand going forward, is anytime you are looking at any emulation, a LUT or a plugin that offers to output you into a non-display color space, some version of this pipeline has been used. And that's a really important thing to understand. Now, that might bother you. That might not bother you. It might be a problem for your workflow, or it might not be a problem for your workflow. It's just something that you want to go into with full awareness of. And I also want to show you the alternative. If it does bother you, if it no longer feels like the best thing for your workflow, I want to show you a really simple alternative, because as you might know, I make a film emulation plugin in partnership with my partners, Dr. Mitch Bogdanowicz and Steve Yedlin, ASC, called Genesis. Genesis does not have the option to output into anything but a display color space. The reason why Genesis is designed in that way is because we ultimately felt that doing this workflow, where the image is never going to get better and is at best just going to be as good as it was before, was not actually a benefit to the end product or to the end user. So we chose to create a plugin that only does what real film does, which is to put you out onto a display. Now, what if you want to do the same? What if you're like, hey, I don't want to go through this pre-inversion just so that I can work within the DRT of my color management framework? What do I have to do? Do I have to go and grab this Genesis plugin? I'm going to give you a much simpler free solution available right here within Resolve. Check this out. Grab these two nodes, turn them off. That's it. Just let the print do its job. Let this be your DRT. Let it do exactly what it was designed to do, which is to put your pixels on the screen and then do all of your grading over here at the clip level, just like you normally would. If that's something that you are open to exploring, that you feel like, hey, it's time for me to try another approach than doing this pre-inverse to make things work within my color management framework, this is a great alternative. There's no arguing this is gentler on your image, and you can get great results doing things this way. And the only caveat or downside to this is that you're not using the exact same workflow that you are familiar with. But that really leads me to something that I brought up right at the beginning of this video, which is like, okay, so what is the reason? Why do we find it so difficult to emulate film digitally? Like, why is it this moving target that everyone's always chasing and so often falling short of? One of the main reasons for that, in fact, the main reason for that, is that we say we want the film emulation. We want the film look. We want the film system, but we want it to come to us. We want it to work the way we are used to things working instead of wanting it to work the way that it works. That's where we run into this tension where it's like, well, we want A, but we want it to work in a different way than it does. And that's where the difficulty arises in getting a really, really faithful, idealized filmic rendering of image or photochemical rendering of image. Is if we really want that, we need to meet the system, we need to meet the look more on its own terms, which again, in this case, would be to simply let the look and the system do its job. Let that output transform come from the print, which was designed to put your pixels on the screen. So that's a great way to, a great opportunity to start exploring doing things a little bit differently than your normal color management framework would call for. And by the way, this is still color management. You're just using a different DRT. You are using your film print as your DRT. It's totally valid. It can work beautifully. And in fact, it's probably going to net you better results because you are doing less to your image and you're being a little bit gentler on your image. So I hope that's a really helpful walkthrough for you of how you can build out film emulations using the right ingredients, many of which are free and available right here within Resolve, and build film emulations that I would put up against, when you've got the right ingredients, you can put these up against any product or tool that's out there and compare for yourself and see what you get and see what kind of differences that you observe. Last thing that I want to point out to you actually is if you ever want to get like a source of truth or a reference point, go grab a free trial of Genesis, my plugin that I mentioned a moment ago, and use it to compare. So I'm going to load Genesis on here and I'm going to connect it up to the head of this node graph like so, okay? And you can now compare and at least start to get a sense for like, okay, am I in the right ballpark? Is my contrast ratio, is my color rendering, is my saturation feeling good? Or is what I'm building manually up here in the top feeling really far flung from the photochemical model that I'm seeing represented here by Genesis below? That might be a good clue that you want to go and look at sourcing some different ingredients for your neg or for your print, or that you just want to double check that you're following the exact process that I've walked you through today. But go grab a free trial of this plugin and it can be a great reference point for you when you are building your own film emulations of whether you're getting into a sound baseline position for things like contrast, saturation, and color reproduction, or whether you want to look at sourcing some different ingredients or double checking that you have set up your pipeline to run in the correct way. So hope you enjoyed that walkthrough. I know that's a long one. Let me know in the comments what questions you have. If anything, go and give this one another watch to absorb the different kind of twists and turns along the path here. And I promise this starts to become easier to understand with a little bit of practice. And this can be a really powerful way. In fact, this is the very best way to build a scene referred film emulation or a color management friendly film emulation, if that's your goal inside of Resolve and you're trying to get that film emulation to work within your established color management workflow.